Okay, everybody. Today I am here to talk to you about how we can take what we have learned about these quadratic functions that are in vertex form, and we can actually go about graphing them. So I want to remind you of this is our vertex form, y equals a. Remember, a is the value that makes your parabola wider or skinnier. We say a vertical stretch or a vertical shrink, or it could flip it upside down and be reflected across the x-axis. And then we have x minus h. I think h is that horizontal movement. It moves my parabola left or right. And then at the end, the plus k, that's what moves my parabola up or down. So looking at that format, my vertex would be hk. So the vertex is really the most important part of your parabola that you need to figure out first. So if I look at number one that I wrote here on my paper, first thing I want to do is I want to find the vertex. And so my vertex is going to be positive 2, positive 3. That's going to be my vertex. So if I go to graph this, I'm going to put my vertex on 2, 3. Now, every single parabola is going to have an axis of symmetry that goes right through the vertex. And the next thing I'm going to do is I'm going to look at my a value. Now my a value, notice there's nothing out in front of here, that's going to be 1. So an a value of 1 is really easy because from the vertex I go over 1 and up 1. And I'm going to do that on both sides because remember we have that symmetry there. Also from the vertex I'm going to go over 2 and up 4. And then I can count, 2 away from the axis of symmetry, 2 away on the other side. And if you have room, you could do another one. From the vertex, you go over 3 and up 9. So that would be here. And again, that would be 3 from my axis of symmetry. So I'm going 3 on the other side. And that's all I need to do. So notice I didn't make an XY table at all. Obviously, this is rough here because I'm drawing with my finger, but you guys kind of get the idea. But I did not need to make an XY table at all, and I could completely graph that parabola. Now, to tie into what else we learned, this parabola does not touch the x-axis at all. So if this equation, if the y were changed to a 0, there would be no solution because that parabola does not touch the x-axis. Okay, so let's take a look at another one. I'm going to go ahead and look at this number 2 that I wrote down here. So step 1 is to decide what is the vertex. So another thing that I mentioned is that we want to square a 0. What would x have to be in order for us to square a 0? It would have to be negative 4. And so negative 4 plus 4 is 0, 0 squared is 0. I just found my vertex. You also can look at this vertex form over here. Remember, it's x minus h, so this would be x minus a negative 4. So that's why negative 4 is the x-coordinate of your vertex. So back to my graph here. I'm going to plot my vertex first, which is negative 4, 0. So right there is negative 4, 0. Okay, and because that's my vertex, I have an axis of symmetry right there. And now I look at my a value. So vertex first, then a value. My a value here is again 1 because there's nothing in front of that. An a value of 1 is awesome because from the vertex I go over 1 and up 1, but I also go over 2 and up 4. I also go over 3 and up 9. If it can fit on the graph. And then all of these have a match on the other side because we are symmetrical here. And so there is my parabola. Okay, now let's talk about where this parabola touches the x-axis. It touches the x-axis in one spot, which happens to be negative 4. So if you were solving this, if this were a 0 equals x plus 4 squared, the answer would be negative 4. We call that the solution to the equation. It's also considered the root of the equation. It's also called the 0 of the function. And that's an important thing. We can see visually that it touches the x-axis there at negative 4. So that would be an example of a quadratic function or quadratic equation that has one solution. Okay, moving on to number 3. Okay, here we are again back to number 3. So number 3, first step is going to be to find the vertex. So the vertex here is going to be a negative 1, negative 5. And I know that part's always tricky when it's inside the parentheses here. You can think, what would x have to be for me to square a 0? It would have to be -1. -1 plus 1 is 0. 0 squared is 0. 0 minus 5 is -5. So this is my vertex. Otherwise, you look up here and it says x minus h. So this would be x minus a -1. So vertex is -1, -5. So that's the first thing that I always want to put on the graph. So I'm going to have to move this down a little bit. -1, -5 is going to be right here. That's my vertex. Of course, with my vertex, I now have an axis of symmetry. Oh, that was really bad. And then you go to the a value. So vertex first, then a value. And number 3, my a value is again 1. I don't see anything there, so that's a 1. But I love an a value of 1 because from my vertex, I go over 1 and up 1. I go over 2 and up 4. I go over 3 and up 9. I think I counted that right. And then that's 3 away from my axis of symmetry, so I'm 3 away on the other side. I'm 2 away, so I go 2 away on the other side. This is 1 away, I'm 1 away on the other side. And so all those points there gives me enough information to sketch that parabola. Now, let's talk about where this parabola is touching the x-axis. And of course, with my finger trying to do this, it doesn't touch really nicely, but I can tell that it's touching somewhere between like 1 and 2. Over here, it looks like it's -1, 2, 3, like a little bit more than -3, somewhere between -3 and -4. So it's not a nice, neat number. If you needed to figure that out, you know, there's other ways that I'm going to teach you later on that we can figure out exactly where it touches, but this at least gives us an estimate. If you were using the free graphing calculator, I should just go ahead and show you that. Hang on. The free graphing calculator, if I type this one in, so again, I'm talking about this number 3 here. This would be parentheses, x plus 1, quantity squared, minus 5. This one I want to clear out. And so you can see it's a little bit nicer here. And if you double tap and you go to find roots, remember these x-intercepts are also called roots. And so I know that's really crazy up there, but the x value, that's where it touches the x-axis. This is really, really, really close to 0. It's having a hard time finding exactly where that is. So we would say that this touches at -3.23 approximately, and then over here, this touches at 1.24, something close to that. So it's not a mess. It is a messy spot where it touches, but you know, sometimes that happens. So that's another way, if we have the graphing calculator, that it works out nicely. But with my rough sketch here, I at least knew a general idea of where that was touching. I am now going to move on. Number 4, real quick, I'm just going to talk about the vertex. Because you don't see parentheses here, that means there was no horizontal movement. Again, if you want to square a 0, your x would be 0. So 0 squared is 0, 0 plus 2 is 2. So your vertex is 0, 2, and you know, you would put 0, 2, and then you go over 1 and up 1, over 2 and up 4, and you get that parabola. But I want to talk about number 5, where we introduce this a value that's not 1. So if I'm going to graph that, I'm again going to start with my vertex. So you see there's no parentheses, which means there's no horizontal movement. So that means 0 is going to be the x coordinate of my vertex. Again, I want to square a 0. So 0 squared is 0. 0 times 3 is 0. 0 plus 4 is 4. So 0, 4 is my vertex. So I will put that on the graph. 0, 4. Oh my gosh. 0, 4. And now we do the a value. So the a value, because it's 3, that's like a free point. So from my vertex, I'm going to go over 1 and up 3. I say we always go over 1 and up the a value. So when the a value was 1, I went over 1 and up 1. And because it was 1, I could also do, you know, over 2 and up 4 and over 3 and up 9. That doesn't work when my a value is not 1. So just to keep track of what we're doing here in this XY table, from my vertex, when I go over 1, I go up 3. And again, my axis of symmetry is going to be the y axis this time. So I get these 3 points. Now, I'm probably going to need another point to figure out you know, what's happening to my parabola. So I'm going to plug something in for x because this always works. I just didn't have to do it on any of these because my a value was 1 and that made it a lot easier. But here I'm going to have to find another point. Now looking at what I already know, I know this point, which is when x is -1. I know this point when x is 0. I know this point when x is 1. So I like to work to the right. And because I can tell that this was like a vertical stretch, it's going to be a really skinny parabola, I'm going to go to the next spot, which is x is 2. So that's what I'm going to plug in. When I plug it in, you always follow order of operation. So you say 2 squared is 4, 4 times 3 is 12, 12 plus 4 is 16. So I'm going to move my graph here. Now, this is an ordered pair. It's not like from the vertex, it's an actual ordered pair. So we go over 2 and up 16, and that's that point. Axis of symmetry is the y-axis, so it's, you know, equally spaced on the other side. So again, you can see this is really a, you know, a skinny parabola. I'm going to try to sketch it. Ooh, we call that a vertical stretch. Think about a rubber band, you know, stretching vertically. It's nice and skinny. And that's because your a value was more than 1. If your a value is less than 1, then it would be a vertical shrink and it would be like a wide parabola. Okay, so I'll do one more with you here. And you know what? I'm going to go ahead and I'm going to change this to 1/2 just so I can kind of show you the difference. I just made these problems up on the fly, so I'll just change it because I made it up. Okay, so this one. First thing is to find the vertex. So the vertex here is going to be 4, 5. And if you have a hard time with that, we look at this, you know, vertex formula here. Or you can say, I want to square a 0. What would x have to be in order to square a 0? It would have to be 4. 4 minus 4 is 0. 0 squared is 0. 0 times 1/2 is 0. 0 plus 5 is 5. So my vertex is 4, 5. So now I come to the graph and I put a point on 4, 5. And this is the vertex. Because that's my vertex, I have this axis of symmetry that goes right through the vertex. And now I get another point, which is the a value. So an a value of 1/2 is actually not very helpful because from my vertex, I'm going to go over 1 and up 1/2. So, you know, it tells me something, but it doesn't really tell me a lot. I'm going to need more points on here to really figure out what my parabola looks like. So that means we're back to an XY table because that always works, but we're going to decide what to plug in. So what I already know, I know when my x is 3, I know when my x is 4, I know when my x is 5. So I might want to figure out when my x is 6. Because this is a wider one, I might even skip 6 and try 7. So I'm going to go ahead and I'm going to plug in a 7. When I plug in a 7, I say 7 minus 4 is 3. 3 squared is 9. 9 times 1/2, so we're saying 1/2 of 9 is 4 1/2. Plus 5 is going to be 9 1/2 or 9.5. So if I put that, and that's an ordered pair, so over 7 up 9 1/2, if I put that on my graph, over 7 up 9 1/2, it's right there. And then that's 3 away, so I'm 3 away on the other side. That is going to give me enough information to kind of sketch my parabola. Now, what if somebody would have plugged in a 6? Well, then you probably would have gotten a point, you know, somewhere around in here. But by skipping, it kind of gave me a better picture of what this parabola really looks like. Okay? And again, where does this parabola touch the x-axis? It does not touch the x-axis. So if we were trying to solve this related equation, then there would be no solution because that's about where the parabola touches the x-axis. All right, that's all for today. Thanks, guys.